Hi, this is Sowjanya. Today I'll talk about sentiment analysis or emotion analysis, a technology that helps machines understand human emotions from text data. So, what is sentiment analysis? It is a process of identifying emotions in text data. It helps machines understand human feelings from written content. And also, if I want to introduce sentiment analysis, it mentions how companies react to customer feedback quickly and also give relatable examples like emails after negative reviews and also content recommendations. Explain sentiment analysis is behind this. So and also it has wide range of applications. For example, have you ever left a negative review and suddenly got an email apologizing? Or noticed how YouTube and Netflix recommend content that matches your mood? That's possible because of sentiment analysis. Sentiment analysis allows machines to interpret the emotional tone behind words, whether it's happy, angry, sad, or sarcastic. From analyzing product reviews to monitoring public emotions during elections, sentiment analysis has countless applications. And coming to the next slide, it's like why sentiment or emotional analysis. Like it highlights the needs for machines to understand human emotions, and also it stressed on the vast amount of unstructured digital data. Like it explained who benefits from sentiment analysis, like companies, mental health experts, political analysts, and shared the data statistic like 90% of the world's data created in the last 2 years. So it allows to interpret the emotions behind the data, and also it has many applications in business, social media, customer service, healthcare, and also more. It helps in understanding emotions, so which is key to building empathetic AI systems. But why do we need machines to understand emotions? Because we live in a digital world where millions of people share opinions every second in tweets, blogs, chats, and reviews. Companies, mental health professionals, and even political analysts want to make sense of this huge data and respond appropriately. So let me share one of the fun fact, like 90% of the world's data has been created in just the last 2 years, and most of it is unstructured text. And this is one of the image, like it has many emotions like surprised, happy, sad, excited, frustrated, angry, fearful, disappointed, hopeful, anxious, and also content. So coming to real life examples, like we have many examples of sentiment analysis applications, like social media monitoring for brand reputation. For example, brands like Starbucks monitor tweets to know what customers feel about new launches, and also want to do a customer feedback analysis. Amazon summarizes thousands of reviews to help buyers, and mental health tracking using journal or chat data. Apps use sentiment analysis to track users' mood patterns. In fact, even governments use it during elections to understand public opinion. And also movie or product review summarization. Once we watch the movie, we just want to know the review, or once we purchase a product, we just want to know the review. So that review summarization can also be done. And coming to the next one, so what is a problem statement? Here, like sentiment and emotion analysis aims to determine the underlying emotion in a given piece of text. So the goal is to detect true emotions from text. Like text emotions are complex and tricky. Language is ambiguous, sarcastic, culturally dependent. So textual emotions can be complex due to contextual nuisances, cultural differences, ambiguity in language. So sounds great, right? But it's not so simple. The main goal is to detect true emotions from text, but language is tricky. Emotions are often hidden, sarcastic, or culturally specific. For example, when I say, that's just great, am I being genuine or sarcastic? Machines struggle to understand such nuances. So, we have few challenges too. So, key challenges are like ambiguity in sentiment, Like words can mean different things depending upon tone. For example, that's just great. It might be sarcastic or genuine. And also domain specific sentiment or context specific words. Words like hot have different meanings in fashion versus weather context. So hot can mean warm, spicy or trendy. And also multilingual sentiment analysis, accounting for linguistic variations and translations. So different languages, slangs, dialects, etc. Lack of large label datasets, especially in specific domains or rare languages, especially in regional or domain specific contexts. Machines need a lot of context and examples to understand human emotions. And coming to the next slide, it is like methodologies. We have different methodologies like traditional approaches, where rule-based models using dictionaries, and also we have machine learning based, naive based, SVM, random forest, and also deep learning based like RNNs, like LSTMs, transformers, like which includes BERT and GPT. So I'll go through each of the methodologies like traditional and also what are the rules we have and machine learning and also deep learning based. So moving to the next slide. So we have traditional approaches or traditional rule-based approaches. So what is a rule-based sentiment analysis? Rule-based approach is one of the earliest methods used for sentiment analysis, where predefined linguistic rules, lexicons, and sentiment dictionaries are used to determine the polarity of text, like whether it is a positive, negative, or neutral. It relies on human curated lists of words tagged with sentiment scores. So examples of such dictionaries are CentiWordNet, AFINN, and also Badder. So let me go through each of that. So coming to CentiWordNet, so what it is? It is a lexical resource based on WordNet where each word is assigned three sentiment scores: positive, negative, and objective, that is neutral. So how it works? Like it works like each SynNet, like group of synonyms in WordNet, is given a score between 0 and 1 for positivity, negativity, and neutrality. So use cases helpful in academic research and when you want fine-grained sentiment scoring at the end or synonym level. And coming to AFIN, it is a list of English words rated for sentiment polarity where each word is assigned an integer score between -5, that is very negative, and +5, that is very positive. So it uses single words and assign them a score based on emotional intensity. For example, happy, it's like +3. Terrible, it's -4. And quick and lightweight sentiment analysis, especially suitable for social media text and short sentences. And coming to the next one, it's a WADR. WADR stands for Valence Aware Dictionary and Sentiment Reasoner. So what it is, like WADR is a rule-based sentiment analysis tool specifically designed to analyze social media content and short text. So it combines a sentiment lexicon with rules to handle uh, like capitalization, for example, good, a stronger positive, punctuation, exclamatory, it increases intensity, degree modifiers, it's like very happy, emojis and slang. So we have use cases like ideal for analyzing tweets, Facebook posts, comments, or any short informal text with modern language, emojis, and abbreviations. So how does it work? It scans and tokenizes the text into individual words or phrases, matches each word with the sentiment score in the dictionary, aggregates the score to compute the overall sentiment of the text. For example, the sentence like the movie was good and enjoyable. It's a good positive, enjoyable positive. Overall sentiment is positive. So coming to the advantages or pros and cons of this, so it is simple and easy to implement and interpret. So no need for label training data and also transparent decision making process. Suitable for small data sets and specific use cases. Fast execution due to simple rule matching. And coming to disadvantages, cannot capture content, sarcasm, or complex sentence structures, like fail to detect slang, idioms, domain specific terms. And also coming to the next one, so this is an image, and coming to the next slide, that is a machine learning based approaches. So this approach automatically learns to predict sentiment based on label data without predefined rules. It applies statistical and probabilistic models to identify patterns and make predictions. See, common algorithms like naive Bayes, like which uses word frequency and conditional probability. Support vector machine, that is SVM, separates sentiment classes with a hyperplane. Random forest uses multiple decision trees for better prediction. Logistic regression predicts the probability of a sentiment label. So how does it work? It requires a label dataset, and also it extracts features like bags of words, TF-IDF, that is term frequency, inverse document frequency, and also n-grams. So coming to the purpose, it highlights like importance and unique words in document while ignoring common words. For example, if the word movie appears frequently in all the documents, its weight will be low. But if masterpiece appears only in one document, it gets a higher weight. And also like how it works, trains the model to find relationships between features and sentiment, predicts sentiment on unseen data based on learned patterns. For example, a data set with 10,000 product reviews labeled as positive or negative plus model train can predict sentiment of new reviews. So we have pros and cons of this. Coming to advantages, it can generalize better than rule-based models. It handles a wider variety of inputs, better accuracy on larger data sets, and models can be fine-tuned for specific domains, adaptable to evolving language. So we have disadvantages too, like it requires a large label dataset, needs feature engineering, and also performance depends on quality of data and features. Like struggles with complex linguistic phenomena like sarcasm, irony, and less transparent decision making compared to rule-based models. And coming to the next one, that is a deep learning based approach. So what is a deep learning based approach? It's like uses advanced neural network architectures to automatically learn intricate patterns, relationships, and contextual meaning in text data. So it eliminates the need for manual feature engineering. So we have common architectures like recurrent neural networks, that is RNNs, good for sequential data like sentences, and also sequential text processing. Long short-term memory, LSTM, specialized RNN variant to capture long-term dependencies. Convolutional neural network, that is CNN, captures local pattern in text. Transformers, example BERT and GPT, like uses self-attention mechanism to understand deep bidirectional context. And how does it work? It processes large volumes of labeled text data, embeds words into dense vector representations like word2vec, glove, BERT embeddings. Neural networks learn to understand sequence of words, capture semantic meaning, detect complex patterns like negation, sarcasm, and idiomatic expressions. Example: BERT fine-tuned on the IMDb movie review dataset achieves state-of-the-art accuracy in sentiment classification. It has advantages too and disadvantages. Like it captures deep contextual information and handles long sentences, complex structures, sarcasm, and slang, and also learns semantic meaning and word relationships. So no need for manual feature extraction here and continuously improves with more data. And coming to disadvantages, like requires huge label data sets and computational resources like longer training times and higher cost. Often considered black box models plus hard to explain decision process. Risk of overfitting on small data sets and also requires expertise to fine tune and deploy. And coming to the next slide, it's evaluation metrics. To measure how good or how accurate a sentiment analysis model is, we have common metrics like accuracy, measures how many predictions were correct overall, and also precision, like out of all the times the model predicted positive, how many were actually positive, and recall, out of all the actual positive cases, how many did the model correctly predict. And F1 score, harmonic mean of precision and recall, useful when you need a balance between precision and recall. And also confusion matrix, a table showing true positives, false positives, true negatives, and false negatives. Helps visualize how many correct and incorrect predictions the model made. And also sentiment specific scores. So sometimes we calculate positive and negative or neutral proportions to understand overall sentiments in a data set. So and next we have a case study. Let's imagine you are a movie lover who always reads reviews before watching a film, but there are thousands of reviews, some are positive, negative, sarcastic, and completely confusing. So now think of a machine that can quickly read all those reviews and tell you the overall sentiment, is a movie worth watching or not. That's exactly what researchers did using a power model called BERT. They took in the IMDb movie reviews dataset, which has thousands of reviews labeled as positive, negative, or um, like negative. Instead of teaching a model everything from scratch, they used a technique called fine tuning. They took the pre-trained BERT model, which already knew a lot about language, and trained it specifically on movie reviews. So what is the result? The model became so good at detecting the true sentiment of reviews that is outperformed traditional machine learning models like Naive Bayes and SVM. Whether the review was straightforward or sarcastic, BERT could understand it much better because of its deep conceptual understanding. This is how deep learning is transforming sentiment analysis, making machines not just read but actually understand human emotions. And we have future directions too. Like sentiment analysis has come a long way, but there is a room to grow. Context awareness, like adding real world knowledge, multimodal analysis, like analyzing text, images, voice together, and zero shot learning, like analyzing languages or domains without training data, and explainable AI, making models explain the decisions. So I just want to conclude to know whatever I explained. So to conclude, sentiment analysis is more than just positive or negative labels. It is about making machines understand us, our thoughts, emotions, frustrations, and happiness. Whether it's a product review or a tweet about mental health, this technology is making the digital world more human. It's about understanding frustration in a tweet, excitement in a product review, or mental health signals in general entries. So, this technology is making the digital world more human centric. So, at the end of the day, sentiment analysis is not about data, it's about people. It's about helping machines understand us so that they can better serve us. So, thank you.